This is part 2 video for Chapter 4B, Simple and Compound Interest Outline. We're continuing the problem that we were working on here. And let's see if I can get to where we were. So we talked about we're now looking at, we looked at simple interest to see how much we would make on our money if we let the bank use it. And we're going to compare that now to compound interest. Compound interest pays interest on your original investment and anything that is added. So we already computed it's the same $1,000 we're giving a bank. We get the same 5% interest, but the difference is that it is compound interest, not simple interest. So we do the same thing. We take our 5%, which is 0.05, and we multiply it times the $1,000 that we gave the bank, and we get an answer of $50. So that's what we get for letting the bank use our money for 1 year. Now remember, here's what's different. You take that $50 and you add it to what you had in your account, which was $1,000. So now we have 1,000 plus the 50, which gives us the 1050, which is listed here. Now what happens? So the second step would be to take what's in our account now, which is the 1050, and the 5% gets multiplied by the 1050, not the original 1,000, because we get to add in the interest. So if you take your calculator and take 0.05 times 1050, you should get an answer of 52.50. So the second year, you made $52.50. What is the new balance in your account? Well, we have to take our original, our 1050 that we had when we started, and let's add to it the 52.50. And we will get an amount of $1,102.50 as our new balance. Now it says, what's the balance at the end of 3 years? 3 years, so we start all over again. We take our balance, which is my pen is not working for some reason, 1,100, oops, let's erase that. That's a mess. Let's see if we can get the eraser to work. Okay, back to your pen. We take our $1,102.50 times our 0.05 again, and this time we will get what? Let's see here by calculator. I don't have that worked out, so I get 1102.5 times 0.05 equals 55.13. And we add that to the $1,102.50, add it to 55.13, and we end up with a balance after 3 years of $1,157.63. Notice the difference in 3 years. Up above, our simple interest in 3 years gave us a total of what, $150. Compound interest gives us a little bit more. It gives us a total, well, in our bank account, we have $157.63 that we made in interest. So it is a bit more in compound interest. But now think about this. That's because our interest was only paid once a year. Sometimes the bank compounds more than once a year. It'll compound quarterly, which means 4 times a year, or every 6 months, or monthly, every single month. If you can get a deal like that, that's what you want, because they're giving you money on top of more money each month. So let's look here at our compound interest formula for interest paid once a year. Again, here's the formula. Okay, we worked it out, but here's the actual formula. A equals P times 1 plus APR Y, where A equals the accumulated balance. That's what we're trying to find, the amount. The accumulated balance after Y years. P is equal to your starting principal. It's the money that you gave the bank when you first opened your account. Ours was $1,000. Our APR is the annual percentage rate. That's what that stands for, annual percentage rate. And that's any percent. And the minute you see it in the problem we did, the last one, it was 5%. Anytime it's given as a percent, the first thing you do is change that to a decimal. Don't keep it a percent. And Y is the number of years. How many years are we looking for? So we can figure out what we need to deposit now in our savings account and figure out what we'll have in 10 years from now. So this is a great formula to help you plan for what you want in the future. Now, let's go forward here. And we have that some notes. The starting principal P is often called the present value. You don't have to worry about these definitions. And the accumulated balance is called the future value. Again, you do not have to worry about that, but it is in your textbook, and I thought I'd mention it. Okay, we're going to go to page 55, and we're going to do, or page 222, and do number 55. Now, in fact, you know what? I'm not going to do that one because your book or your videos that show on the Blackboard, they go through an example just like that. It's a long one, but they do a really good job. So I want to go down to the compound interest formula for interest paid n times a year. So not now just 1 times a year, but more than 1 times a year. So let's see if we can change our color of our pen to see if we can get something a little easier to see. And this time our formula is a little bit different. And I did post a page for you of all the formulas we'll use in Chapter 4. Now this is the compound interest formula for interest paid n times a year. Notice we have again, A is our amount, P is our principal, or what we give the bank to begin with. APR is our annual percentage rate, Y is the number of years, and N is the number of compoundings per year. For a period of 6 months, you would use Y equals 0.5 because if the compounding is always given in years. So if it's 6 months, we have to make that 0.05. Okay, so let's try page 214. Let's change that. Let's go to page, this is an old page, 222 in your text, and let's do number 63. So the problem states in our book that we take $5,000 to invest, and it's invested for 10 years with an APR of 2%. And it is quarterly compounding, which means 4. Quarter means 4 times a year. Okay, let's move this down a bit. So let's fill in our numbers for up above. Our formula says that A is our amount, we're trying to find that, equals P. P is the principal, that's our $5,000. Okay, times, and then in parentheses we have 1 plus APR is 2%, which is 0.02. So we have 0.02 over N is the number of compounding, which is 4, N equals 4. So we put that over 4. And that is all raised to the N times Y. Well, N is 4. What was our Y? Our Y is 10 years. 10 years. So this would be 4 times 10. So that's going to equal 5,000 times 1 plus 0.02 divided by 4 to the 40th. The easiest way to do these in your calculator is to start from the inside and do the 0.02 divided by 4. So if you do that 0.02 divided by 4, you will get a decimal of 0.005. Then you want to add 1 to that. So if we add 1 to 0.005, we get 1.005. So now we have 5,000 times 1.005 raised to the 40th power. And when you work that out in your calculator, you're going to get an answer of $6,103.97. If you're not getting that, go back here and start again. Divide this, add 1, then raise that whole thing to the 40th power. Lastly, multiply it by 5,000. Okay, let's look at problem 66. Problem 66 in your book states that we have $10,000. So our $10,000 is now our principal. And we're investing it for 5 years, which is our Y, so Y equals 5. And we have an APR of, our APR equals 2.75%. Do the same thing, go left 2. So we have 0.0275. That is our APR. And it is monthly compounding. Monthly compounding means every month they're doing it, so our N equals 12. So now let's substitute our numbers in quickly because the video is almost done. And we will get A equals $10,000 times 1 plus 0.0275 over our N, which is 12, all raised to the 12 times 5. And if you work that out, your answer, try to do that on your own, your answer should be $11,472.21. Hopefully that helps you have a little bit more understanding of compound and simple interest.